Hello, everyone. Welcome to our class on advanced functions. Today, we are going to start with the second unit, which is on rate of change. We have already covered what are functions, and we have also discussed what are polynomial functions, their characteristics, how do we sketch, and the transformations regarding them. Now, when we are taking rate of change, we'll take examples of polynomial functions to discuss rate of change. I'd like you to introduce yourself one by one, and then we'll start our class. Akshit.
Hi, my name is Akshit Candyvanam. I'm currently in the summer of grade 11, going to grade 12 next year, so I thought it would be best to prepare for advanced functions.
Vishruta.
Hi, my name is Vishrutha. I'm going to grade 11 and I'm doing advanced functions in the summer to get ahead of my class.
Hamza.
My name is Hamza. I'm in the summer grade 10 going to grade 11, and I'm trying to learn advanced functions here so I can have a better understanding going into next
year. Perfect. Till now, do you have any difficulty, any one of you? Everything absolutely clear? You have done some questions from your book. Any difficulty from that place? Any questions? No? Okay. So let's continue. So you need to do questions from your book also when I teach, right? And you're doing well, that means, if you don't have any questions. Okay. Right. So this is my lesson on rate of change. We'll discuss what is rate of change. Now, do you have any idea what is rate of change?
So isn't it slope?
It is slope, yes. In a way, rate of change is slope or gradient, as we say, correct? That is what really the rate of change is. Let me reduce this a bit because a portion of it is not visible. So can you still see the screen, right? Okay. I think now it's better. Perfectly fine. So rate of change is, as Akshat is saying, gradient. Now, gradient. Akshat, can you please read what have I written as a definition of rate of change?
Yes, sir. Average rate of change is the ratio of change in the dependent quantity with the respective change in the independent quantity.
Correct. So basically, whenever you draw a graph, in that case, you draw independent quantity x along the x-axis and the dependent quantity along the y-axis, correct? That is what we do. And now, when you draw a graph, it could be any graph, for example. Perfect. So when we are interested in finding, we're looking now into the word average rate of change. That means at any 2 points, if I draw a line, we want to find what is the rate of change from here to there. That is the average rate of change over a period of time. Like it's very practical. When you are driving, let's say I have to drive to Niagara Falls, correct? So sometimes my speed could be 100 kilometers per hour, sometimes 60 kilometers per hour, sometimes 80 kilometers per hour, something like this, right? So we, at the end of it, check what is the average, correct? So that is kind of very important. So we have 2 points. And between the 2 points, we see what is the distance and what is the time taken. Dividing distance by time, we get the average speed. Is that clear to you? That is the simple concept of average rate of change, correct? So time is the independent variable there. Distance is dependent on the speed. Perfect. In this particular graph, I've just drawn a very, very general graph like this. X is the independent value, Y is dependent on that, and we get some curve. We have taken 2 points, and joining these 2 points, whatever we get is called a secant line. So this, from here to here, when we join 2 points, what we get here is called secant. If you want to find rate of change, basically, we are finding what is the difference in Y position. So we call this as delta Y, right? And what is the difference in the X position? Their ratio or quotients, right, is rate of change. So the rate of change is basically delta Y over delta X, correct? Very simple. So that is what rate of change is. You are very familiar with straight lines. Straight lines have an advantage. That is, rate of change is constant between any 2 points, correct? On this curve, you will notice that if I draw some other line, for example, I draw this line here. Let me let's say I draw this line, correct? You can clearly see that the gradient or the slope of this line is different from the earlier line, correct? Whose rate of change is higher?
The one you just drew.
Correct, because it is more steeper. So steeper the line, higher the rate of change. Perfect. If I draw a line which is, let us say right there, right, which is kind of a horizontal. Can you tell me what is the rate of change of this line, which is kind of a horizontal line? I could have drawn like this also.
0.
Zero, because there is no change, right? The value of y is not changing at all. So any horizontal line will have zero rate of change. Perfect. On a distance time graph, that means that the body is not moving. The time is going, it's a standstill, correct? But depending on the function, there could be many different reasons for a zero rate of change, correct? Even, let us say,
I have a
we go
question.
to, yes, please.
So the green graph you just drew, can you just remove the lines for a second?
Can I remove what?
So the lines I just drew, I just wanted to show you something about the graph, the green, yeah, the curve you just drew. So the rate of change for this is like constantly changing. So how do you find the
Yes.
average rate of change? So how do you do that? Because you have to find 2 points. You have to find the change of, for example, y, right? So you find 2 points in y. But if it's changing on each point, then how are you supposed to find the average rate of change for y and then find the
The
rate of
term
change?
average rate of change means between 2 points, what is the rate of change, right? So one point could be, let us say this, right? Let us say -2, and the other point could be +2. Is it okay? So what we will do here is that we will write down the value as the value at 2 is, let us say this value, right? Let us say this is 5, and let's say this value is 3. Is it okay? So the rate of change will be 5 minus 3 divided by 2 minus -2. Is that clear? So any 2 points, if I consider the other 2 points, I get a different rate of change. Well, it is going to be different between any 2 points. Is that clear? Perfect. Okay. So now we come back to a definition, that is average rate of change. I will write in short as AROC, average rate of change. In the next chapter or in the next class, we'll discuss instantaneous rate of change. At the end of this class, I'll show you what is the difference between the two. So, okay. So average rate of change is change in y over change of x, delta y over delta x. That means the value of the function at x2 minus value of the function at x1 divided by x2 minus x1. Just as we did now, right? We took 2 points which were at x equals to -2 and +2, their values. F of 2 was 3, f of 2 was 5, f of -2 was 3, and we got the average rate of change as 5 minus 3 divided by 2 minus -2. Hamza, is this absolutely clear, right? Perfect. So you helped me in answering or understanding this situation better. Good question. Now, graphically, average rate of change is slope of the secant line passing through 2 points. Any line which passes through 2 points is called a secant line. Let's understand this definition, right? So a secant line always passes through 2 points. Is that clear to you? We call that as a secant line. Okay.
Sir?
Yes.
So a tangent would be where it just like barely touches one point,
very,
right?
very close. When the 2 points are very close, we'll come to that definition. Yes.
Okay.
So we'll say if the 2 points are very, very close, as if they are at almost the same point, in that case, secant becomes a tangent. And in that case, average rate of change becomes instantaneous rate of change. You get the idea? So it's good to introduce the term, right? Yes, Akshay.
Sir, I remember in physics, we used tangents to find instantaneous velocity.
Yes.
So yeah.
Same concept. So if I actually move, let us say, let me use different ink so that, we will be, let's use it. So if this is a tangent, right? So if I move closer and closer, ultimately it will be a tangent becomes, secant becomes a tangent. You get the point? If my 2 points are coming closer and closer, right? So at that time, I will say instantaneous rate of change. Is that clear to you? So I will say, well, let one point be, let us say f of 2. The other point is f of 1.999. Very, very close. You get the idea? So the second point is there, but very, very close. The difference is between 0.001, we'll say almost same point, correct? So that becomes the tangent in our calculus. Is that clear now? Okay.
Yes, sir.
So now we'll begin with a very simple example. You know the equation of a line, right? Which is, okay, and you know what a slope is. So if we have 2 points P as x1, y1 and y as q2, x2, y2, in that case, you know what slope is, y2 minus y1 divided by x2 minus x1, correct? And the equation of the line is y equals to mx plus b. So whenever we want to find equation of a secant or a tangent, we need 2 points, right? And the slope, correct? Or point or a slope. And that combination gives you the equation. Here is example number 1. Vishruta, can you please read the example and answer?
It says m equals y2 minus y1 over x2 minus x1 equals
Correct.
0.
We are okay, right. We are considering, I didn't write the whole question, so my mistake. So we are considering the graph here. So from this graph, we have to find what is the rate of change. And we can consider from the graph the 2 points, the y-intercept and the x-intercept. Does it make sense to you, right? So we have these 2 points. You can read any 2 points, but these two are very clearly seen here. So we see that one of the point is what? This is 0, 4, right? The y-intercept, and that point is 2, 0. So we have 2 points to find the slope. y2 minus y1 divided by x2 minus x1, 0 minus 4 divided by 2 minus 0 gives us a slope of minus 2. If the secant is going downwards, that means slope is negative. Rate of change is negative. Is that clear? If it is upwards, it means positive. If it is horizontal, 0. Perfect. So we have found very easily the slope, which is also the rate of change. Now, average rate of change is therefore minus 2. We can also find equation of this line since we know the y-intercept is at 4 and the slope is minus 2. So the equation of this line is y equals to minus 2x plus 4. Clear? Just a quick review of what you did in grade 9. Okay, great. So here is now an example for you. So we have a figure which shows some positions A, B, C, D, and E. Now the question here is, find slope of segments A, B, B, C, C, D, D, E. Identify parallel and perpendicular segments. Write equation of line B to C. And we have just written all the coordinate points of A, B, C, D. Now, how do you find the slope? Very simple example. You have been doing so many times. So a quick review. We just go through the slope as y2 minus y1, find it out, and we know that. Since we want to find equation of the line BC, let's look into the slope of BC, which is this particular line, correct? So 2 minus 2 divided by, no, that is not BC. 2 minus 4 divided by 6 minus 2. We get a slope of minus half. So negative was expected. Perfect. So we get slope of minus half. To find the equation of this line, what will you do? Since we know that the slope is minus half, you will say, well, there you go. We'll write y equals to minus half x plus b. And to find the value of b, we'll pick up any one of those 2 points. If b is 2 and 4, substituting 2 for x, 4 for y, we get the value of b as 6. And so we get the equation of our line. Clear? Simple as that. So that is how you're getting equation of a line from the graph. Now, can you tell me from inspection, which 2 lines are parallel, which 2 lines are perpendicular?
Sir, parallel lines would have the same slope. So AE and CD would be parallel.
Which lines are parallel?
CD and AE.
Pardon? Yeah, these 2 lines. Okay.
Yeah.
And perpendicular lines?
And perpendicular lines.
Line B and sorry, were you speaking?
No, you can go.
Okay. A, B, and BC would be perpendicular. Would be the negative reciprocal, so they would be perpendicular.
Negative reciprocal. So perpendicular line slope will be negative reciprocal, parallel line slope will be same, and that is how you figure it out, right? That was just a quick review before this, because every example will involve finding slope and equation of the line, correct? That is equation of the secant in this case, and the next chapter it will be equation of tangent line. Perfect. So now let's take a non-linear function, f of x equals to x squared. As we discussed earlier, non-linear function will have different rate of change at different points, correct? How do we find the rate of change between any 2 points? So the question here is, find average rate of change of this graph when x changes from 1 to 2. That is your question. That means at 1, we'll pick up what is the value. So we'll just plug in f of 1 and x square means 1. F of 2, 2 square is 4. We got both our points, P and Q. Since we want to find the average rate of change, we'll connect it with a line called secant. And fx2 minus fx1 over x2 minus x1 will give us the slope. In this particular case, 4 minus 1 divided by 2 minus 1 equals to 3. This is the slope of this particular line. Absolutely.
I have a
There's no
question.
problems. Yeah.
So for the step above, find the 2 points and you did that calculation, and 100% it makes sense. But did you need to do that? Because you could just find the points using the grid, right? You could just find
Not
the x
always,
value.
not always. So because I'm just taking my first example and I'm making things very, very easy and simple. The idea here is to understand the concept, right? If I just change this equation to x squared plus 3x minus 1, it will not be so easy, correct? Because the graph may go from somewhere which is not a very well defined on graphically, right? Could have a
Yeah.
decimal or a fraction value. Normally in the test, do not expect such easy values, okay? You will get decimal and then you'll have to work with fractions, okay? But yes, this is the concept and this is the method. So if I am saying from, we sometimes write like this also. Find the rate of change when x value changes from, let us say, minus 3 to 5. Is that clear to you? So you have to find within this interval. So fx1 and fx2, x1 value is minus 3, x2 value is 5. I could also write like this. From, let us say, minus 3 to 7. Is that clear to you? Within the bracket. So there are a couple of notations which will come across soon. These two are also very popular notations to find rate of change. Is that clear? So many different notations. I could say, well, find the rate of change between this, and then I will say, well, between 1, let me write like this, between 1 and 1.5, between 1 and 1.05, between 1 and 1.01, like this, correct? So you can calculate each value. When you do that, and that is what am I doing here? I'm actually bringing the point Q closer and closer to 1. Do you see that? I'm telling you, find the rate of change from x value of 1 to y value of 2. Then from 1 to 1.5, 1.1.01. So I'm bringing it closer and closer. The idea is when you bring it like when I say from 1 to 1.001, that means it is so close that if I draw that secant, in that case, that's in that case, that secant will be like a tangent. You get the idea. Do you see that? So what happens really is that the secant becomes a tangent. And what we were finding, yes.
So when we're given points like 1, 1.5, 1, 1.05, right? So we can just plug in both of these points into the function and then find its output and then just find the slope, right?
Yeah.
Okay.
Use the same formula. This is a formula which you're going to repeatedly use.
Yeah.
Correct? So what you see here is the secant converts to tangent, and so the average rate of change becomes instantaneous rate of change, which is our next chapter. Is that clear to you? So the next chapter will converge these values to a very, very small difference. But we'll say, well, the delta x is approaching 0. Do you see that? 0.001 is kind of 0. Is that okay? So that's the idea. So we'll just move there soon. Now, here's a very interesting question. So I like Hamza. Can you please read the question and answer?
Okay, so 1 second. Find the gradient of the tangent line at P at point P 4/3 and the circle x squared plus y squared equals 25. Hence, find the equation of the tangent line at point P.
Tell me, how will you do this?
Find the gradient of the tangent line. Sorry, can you just tell me the definition? What does a gradient mean again?
Same as slope.
Same as slope, okay. Okay. Find the equation of the tangent line at point P 4/3.
Yeah.
Okay. Would you sub the values of P into the equation to find?
Which equation?
The equation x squared plus y squared equals the equation of the circle.
or you get 25. If you get right 4 square plus 3 square, you'll get 25 because this is on the circle, correct?
Mm-hmm. Okay, that's just one. Yeah, okay.
You have to find basically the slope
Yeah,
of
that's what
this
I'm
line.
just thinking. I'm just thinking for a second because I'm trying to find B. So what would I do to find B?
Yeah, tell me.
Would I sub the 0.4/3 into the equation to find B first?
How will you find B with
Okay, so
your...
I need to find the slope. I need to find the slope first.
Yeah,
So
you have to
I'd
find the
find this.
slope first.
Yeah. So to find the slope, what I would do is I would do 4 divided by 3 to find the slope.
Why?
Okay. So okay, I get something now.
Yeah.
10. Is the bottom part? Is this also clues to do this, or is it just how
This
you
is the
solve it?
solution actually. So don't look at this solution.
Okay. Okay. I'm not gonna look at this. I'm just wondering. I'm like, because I saw perpendicular. I was like, okay, never mind. Okay. How would I find the slope?
Yeah, very interesting question. See, this is the very first question which you are going to hit very soon, right? Akshit. Okay, Vishruta, first tell me, how do we find slope of this red line, which is the tangent to the circle? We are given the center at origin, and we are given a point 4, 3 on the circle.
Because it's a straight line, you would use the equation of a line and
How?
then sub in the x and y.
No, which straight line and which xy? We got only one point there. We need to find slope. Akshat, can you please help?
I don't understand for one thing because
Yeah.
you would need 2 points to find the slope, right? So how
There
would you
are
find
2
the slope
points on the
when you
graph.
given-
Yes, there are 2 points on the graph. You are not using 1 point.
Where's the second? Where's the second?
Or
What's this
Akshat,
one?
can you help?
Yes, sir. So it says find the gradient of the tangent line at that, right, sir?
How?
Sir,
Yeah.
in the solution it says perpendicular, right, sir? But I was trying to
Yes.
figure out how the tangent would be perpendicular.
Yeah,
This is
that's what I
amazing.
wanted to
See,
do. I want
the
to screenshot.
solution is before you. Okay. Now look here. Let me join the point O with P because this is the radius. So it is perpendicular. Do you get this idea?
Oh, yeah.
Do you see this? So O to P, you can find this slope
Right, and inverse. Fine.
and
Yeah.
negative inverse.
Got it.
Yes, Hamza, you got it. Perpendicular line, negative inverse. Easy to say, difficult to apply. Do you see? Where are we getting? We are going to calculus. This is a part of calculus. The very first question in calculus will be this. Okay, find the slope of the tangent line on a circle. They'll give one equation of the circle at this particular point. So this is it. So you know, M will be 4/3 O to P. And that is perpendicular. Therefore, the tangent slope will be negative 3/4. Now we know the point and the slope, and therefore we can find the equation of the line. Correct? So you see, how do we find the equation of a line in a different way, right? But this is extremely important. Now we're getting into applications. Interesting, correct? Akshit, can you please read this question?
Yes, sir. Adam starts 10 meters away from the motion sensor and walks in a straight line toward the sensor at a constant rate of 1.5 meters per second for 4 seconds. He immediately begins walking away from the sensor at a constant rate of 1.5 meters per second for 3 seconds. He stops for 1 second and then walks toward the sensor at a constant rate of 4.5 meters per second for 1 second. Draw the distance time graph.
Correct. This question will be definitely there in your test paper, maybe some different values, maybe a different name. But in last, I have seen at least in 3 papers, Adam is the name and these values. That is why I'm sharing this question with you. Okay, they don't even change the name, you know that. They just copy the questions as such. Now, we will actually answer this question and you need to really work on this question. We say Adam starts at 10. So we do have a rough graph here, correct? So let us say this is 10 for us, right? I'm not making any other values. Okay, let us say this is 10. So Adam starts 10 meters away from the motion sensor and walks in a straight line towards the sensor at a constant speed of 1.5 meters per second for 4 seconds, right? So let us say this is first second, second, third, fourth second, right? Now, tell me, where should be my next point? If think that this is 8, think this is 6, and think this is 4. Tell me, what is the coordinate of the next point?
Sir, so he starts 10 meters away, so his y-intercept would be 0 and 10, right? So you can take that as 1 point, right?
Okay.
And his slope is 1.5. And you know that he does it for 4 seconds. So your next
Yes.
point can be 4 and x, and then you can just solve for
How much you get?
1.5 times 4.
So where will be the
6.
next point? Coordinate of the next point is what? So definitely time is 4. What is the y value?
Would it be 1.5 times 4, sir?
No, it is 6. No. Read the question. All of you help me in this. Read the question. Get me the next point. He's walking towards the sensor at this rate. So, and that means if he walks at this speed, the total distance covered is 6, correct? So what is the net point? Where will he reach? How far? Earlier, he was 10 units away from the sensor. Now he's walking towards the sensor.
Oh,
so the
would it be
distance is
4?
decreasing. It will be 4, correct? You see that?
Yeah.
Do you understand, all of you, please?
Yes, sir.
You will join these 2 points. Is that clear? Next statement. Hamza, read and tell me the next point. He.
Sorry.
Oh, no, he immediately begins. We are here, not here. We are here. He immediately begins. Yeah, we are here. Yes. Hamza. You're on mute.
He immediately begins walking away from the center at a constant rate of 1.5 meters for 3 seconds. He stops for 1 second, then walks towards the center at a constant rate
Yeah.
for
So
4.5
we'll
meters.
stop at the first sentence, right? He immediately. Tell me, where will he be now?
Okay.
Away from sensor. Key point.
Yeah. Okay, so he's gonna start going down.
So what will be the next coordinate point? So 3 means this we got 4, right? Now next, he has walked for 3. That means 7, correct? Y value, tell me. He has covered 4.5 meters during this point. So from 4, he has covered 4.5 meters. In which direction? So that I know what the Y value is.
Sir, would it be 8.5?
Yes, because you're going away. So whenever it is away from the sensor, distance increases. When it is towards, it decreases. And that is how you have to do your calculation as I'm doing here. You're getting my point? Calculate the distance, see whether you're going up and down. This is what you have to do. So 8.5 after 3 seconds. So I'm doing 1, 2, 3, and 4.5, 2, 2, 4, and 1, 5, right? So 4.5, I am going here. Is that okay? So I first came down. You see that? And now next line is, yes, Vishruta, read the next line. He stops. Tell me the next point.
He stops for 1 second and then walks towards the sensor at a constant rate of 4.5 meters per second for 1 second.
Okay, first, he stops for 1 second. What is the next point?
So be a horizontal line.
Yes.
For 1 second.
8.5, 8.8 and 8.5. Same. He didn't change his Y position, correct?
Mm-hmm.
Next, read the next line, Vishruta, and then answer. Then he walks towards the sensor.
At a constant rate of 4.5 meters per second for 1 second.
Yes. So the last point will be 9. And what is the Y value?
Pardon?
What is the Y value?
4.5.
No.
For 1 second.
Yeah. So finally, he is here, right? 8.5. So after 8.5, what does he do? Walks towards or away?
Towards.
That means you will reduce by 4.5, right? So when you reduce by 4.5,
right.
What do you get?
3.5.
Yeah, 4. No, 4 itself. 8.5 minus 4.5, right? You will do it from the previous position, correct?
Oh.
So you came down to same like this. You get an idea. You all understand, correct? All understand, right? Absolutely clear, correct?
Yes, sir.
Very good. Now, let me just do it like this. Okay, no, I'll ask you that question later. Part A. We'll start answering this. Hamza, can you read and answer this question? Draw a distance time graph that corresponds to described walk. We'll do the reverse of this. Now, what you have to do, Hamza, is if I give you the graph, you have to describe this path, not describe.
Okay, so your x value, your x value would be the
No X
the
and Y.
time.
This is a word problem, application. You describe. Let us say Adam, my question is, Adam is walking in a straight
Oh,
line
okay.
before a sensor. Now tell me the journey of Adam, right? Tell me.
Okay. So Adam starts at
Correct.
core. So Adam starts at um Adam starts at coordinate. Should I say in coordinate or
No
should I say?
coordinate. No coordinate. 10 meters away from sensor.
Okay. So Adam starts 10 meters away from the sensor. He walks towards the sensor. He walks towards the sensor at a rate of 1.5 meters.
Okay. You will
1.5.
calculate the rate from the slope, right? You will
Yeah.
calculate the rate, rise over run,
Mhm.
for 4 seconds. Is that clear to you?
Yeah.
Correct?
Yeah. Okay.
And then what happens?
Okay. So 1, 2, 3, 4. 1, 2, 3, 4. What is 4 divided by 3? That would be 1.5. Okay. So then he walks
Away.
wa-
Away. The distance is increasing.
so
Away.
sensor from here. Okay. He walks away from the sensor at a constant rate of 1.5 meters per second. Then he walks toward.
For how much time? For how much time?
For 6 seconds.
No, 1, 2, 3 seconds.
Oh, sorry. Okay, I'm looking at that. Okay, so for 3 seconds, and then he walks towards the sensor.
Stops. He stops. It's parallel.
I didn't get there. I'm at the midpoint right now. I'm at this highlighted the first point. So now I'm gonna walk from this point to that
Oh,
point.
I see. You are still here. Okay.
Yeah.
Okay.
So from here,
Hmm.
for 3 seconds, he's gonna walk at an average rate of. He's gonna walk at an average rate of, what is this? 1 second. 1,
The
2,
scale is 2 units. Rise is 2
2.
units, right?
2, 4 point. So he's
Right.
gonna walk for 3 seconds. He's gonna walk at an average rate of 4.5 towards the
So
sensor.
divide 4.5 by 3, okay? You'll get 1.5.
1.5, right? So 1.5 meters per second. So he's gonna walk at an average rate of 1.5 meters per second for 3 seconds,
Correct.
and then he's gonna stop for 1 second. Then he's gonna stop, and then he's gonna walk away from the sensor at an average rate of 2.
Towards the distance is decreasing.
Yeah. Okay. So so he's walking away at an average rate of
Not away. Towards the sensor, because the distance is
towards.
increasing.
He's walking. Okay, he's walking towards the sensor. The sensor is this way. He's walking towards the sensor.
Correct.
At an average rate of, let's see, 2. At an average rate of, is that 2? Because I see 2. It's going
Each is
down.
2 units. Each is
2
2
units,
units.
right?
2, 4,
Because it's going down
4.5,
to. It's going
4.5 over 1. Each
Okay.
is 2 units. So graph is not 1 unit on y-axis.
Oh,
Correct?
okay. Okay, 4.5.
Real test question which has been asked for 3 times in last 5 years. You understand? And do you think? Okay. Now, welcome to you, Ankita. How are you doing?
I'm good. How are you, sir?
Very good. I knew you're coming late, so we just started. And
Yeah.
this is the first real question on the rate of change, because we were introducing ourselves to the previous concepts, right? So now with that foundation, we are moving ahead. So Ankita, rate of change basically is the slope between 2 particular points, correct? You know, y2 minus y1 divided by x2 minus x1 gives you the slope, and y equals to mx plus b gives you the equation of the line. Now here, we have a lot of application questions, because in real life, distance, time, and all those things are there. And every time what you need to find is the average rate of change. Even, for example, the share values going up and down, we are comparing how fast it is rising. Market prices, right? Everything is becoming so expensive. We are seeing what is happening to the gas prices. So average rate of change is very good to compare. That means we are comparing between 2 points, what was in 2000 and what is now in 2001, correct? And that is what average rate of change is. We have here an example. Ankita, I'd like you to read the example once. Adam, read from Adam.
Adam starts 10 meters away from the motion sensor and walks in a straight line towards the sensor at a constant rate of 1.5 meters per second for 4 seconds. He immediately begins walking away from the sensor at a constant rate of 1.5 meters per second for 3 seconds. He stops for 1 second and then walks toward the sensor at a constant rate of 4.5 meters per second for 1 second.
This is a real test problem which has been asked for 3 times in last 5 years with the same values and same name, Adam. Now, we have drawn the graph, and clearly the graph I'll explain you will understand what it is. So basically from a motion sensor, Adam is 10 meters away. So on the graph, I got a point at y-intercept at 10. Units are meters on the y-axis. Now, when we say that he walks away from the motion sensor, no, Adam 10 meters, Adam 10 meters away from motion sensor walks in a straight line towards. The key word here is towards. So when you're walking towards, the distance is going to decrease. Towards the sensor at a constant rate of 1.5 meters per second in 4 seconds, right? For 4 seconds. So if you walk at the speed of 1.5 meters per second for 4 seconds, distance covered will be product of these two, right? 1.5 times 4, correct? So that is 6. So that means he has come towards it 6, so it decreases. And you come at a point which is 10 minus 6, which is 4. So the y value has changed from 10 to 4, you're coming closer to the sensor. The x value changed from 0 to 4 since you walked for 4 seconds. Is that clear to everyone? This question could be either way. Graph is given to you. You have to explain the motion. Then you have to do all this calculation and write down the rate and time. Is that correct? After that, he walks. Ankita, please continue reading. He
immediately begins walking away from the sensor at a constant rate of 1.5 meters per second for 3 seconds.
Now tell me where will be the next point. This point is 4, and now he walks away at the rate of 1.5 meters per second for 3 seconds. What will be the next point where he's going to stop after 3 seconds? Tell me, calculate. What will you do? The y value changes because he's walking away, so it is going to increase by this amount, which is 1.5 times 3, right?
Yes.
Distance covered is product of velocity and time, right? You can make this particular triangle saying this is distance, this is speed, and this is time, correct? And you get your value. Now this value is 4.5. So basically to the y value, you add 4.5 to get 8.5. And since 3 seconds is the time interval, 4 plus 3 is 7. You get your next point. Plot that point.
Like time is x, so that's why you're adding it to the x value.
So that is how you'll make this graph. I hope the concept is clear. Let's move on to the next question, please, right? Akshat, please read this question. Oh, this is the solution of that question. That was the solution, okay. We've already done. Oh, good. Akshat, this is the last question. Can you please read it?
Yes, sir. Leap of a frog. The height h of t of a frog leap can be modeled as a function of time with the equation h of t equals to negative 5t squared plus 20t, where h of t is in centimeters and time t is in seconds. Find h of t at t equals to 1, 2, 3, 4.
Fine. What is h of 1? Tell me.
H of 1 would just be 15.
H of 2. Use calculator. Tell me the answer.
Okay, 2 would be minus 20. 12. It would be 20, right, sir?
2 square is 4, 4
yeah.
5 is 20. Use calculator. That's why I told you. We don't have time now. H of 3, tell me. Three square is 9. 9 times 5 is 45, and it's a negative value, correct? The frogs can go underwater also, right? So we'll stop it here. Okay, it goes underwater. We are assuming that the same equation will apply, but well, this will not get applied there. But anyway, you got an idea, right? So those values are negative values. We forget about it. Now B, Hamza, can you please read part B and answer?
Okay. Find rate of change of height in the first second, third second, then the fourth second. Oh, okay, okay, good. Thought I meant second, but
So
second.
what is the first second?
15. The first rate of change, the first second would be 1, 0, 1 minus 0.
So height at t equals to 1 second minus the height at 0 seconds. So at t0,
So
what is the height? H of 0, it is 0, right? Is on the ground.
0. Okay, so
So
1.
we'll do h of 1 minus h of 0
15,
divided by
so
1 minus 0.
15.
And we know 1 is 15, so it is 15 over 1 or 15 meters per second. Is that clear to you?
Yeah.
That is how we are going to find the height in rate of change in the first second. Is this clear, Ankita, to you?
Yeah, so you're doing height at 0 just so you can find the difference, right?
So we are doing y2 minus y1 over x2 minus x1, right? Basically, we are doing function's value. Y2 is the value of the function, right? Over x2 minus x1. So first second means when the value of time is between 0 and 1, correct? That is my first second. Now this question, second second. What is the second second? Anybody?
So, would the second still be 1 and 2?
1 and 2 is correct. So the second second will be when t value, that is the second second, right? Changes from 1 to 2, correct? So can we have the answer for this one? 1 to 2, what is the value, right? So yes.
Sir,
yes.
Before we move forward with 1 and 2, I think our h of 2 value is supposed to be 20, right? Instead of 0.
2 square is 4, right? So h of, what equation are you using? Are you using this equation?
Yes, sir.
So let's put 2 here. So it is minus 5, 2 square plus 20. Oh, yeah, you are right. Oh, yeah, I'm sorry. You're good. Yeah. T, 20t. Yes. What was the value? Yes. Sorry.
The value was 20, sir.
40, 20, yeah, you're right. So let's put h of 3 also. Yeah, I didn't see this t. H of 3 also. Tell me. Okay, you can write h of 2, 3, 4. Okay, that's fine. So h of 2 will be this, correct? Yeah, that is, I was also thinking what has happened. Okay, can you find the value now? Rate of change for the second is how much?
So you do 20 minus 15 over 2 minus 1. So it'd be 5.
5 meters per second. Is that clear to you? In the third second, what is going to be the value? So find h of 3, use calculator. 9 times 5, 45 minus and 60. 60 minus 45.
15 again, sir.
15 minus f of 2 is 20, correct? Divided by 3 minus 2, which is again 1. And what do you get? Minus 5 meters per second. Is that clear to you?
So it's minus 5 because the frog is coming down, correct?
Yeah. It's coming down. Yes. So we find that the rate of change in the first case was kind of like this. The second case is this, correct? The third case is this, correct? Something like this. Is that okay? And it's going downwards, correct? What do you notice about the rate of change? Is it always increasing, always decreasing, or increasing and then decreasing? Answer that question.
I think it's increasing then decreasing.
Okay, anybody else?
Sorry, it's increasing on the interval from the left side to the vertex and then decreasing on the right side from the vertex to positive infinity.
Hamza.
I was gonna say the same thing. So from 0.
Correct.
So from the
all of
starting
you are
to
wrong. Very good. Now let us see the values. The rate of change, average rate of change, which we calculated in the first second was how much? Did anybody write?
wait, I think we mistaked it because the rate of change is something. Okay, we're thinking of something different. Okay.
Yeah, I know
think
that.
I understand.
I know that.
I think I understand now. Okay.
So tell me the rate of change in the first second. What was it?
Okay.
Okay, let's go
I think
to
it's
the.
I think it's
If I have solved this, I didn't. I think I did solve this question. I mean, I've solved all these questions. Let me just share with you because where is it? Okay, we didn't solve. Okay, now. Oh, I've written this as an assignment. That's why. Okay, this was your assignment. Anyway, now tell me, what was the first rate of change? 0 to 1. How much was it? Akshit, did anybody write the values?
Sir, I think it was 3, if I'm not mistaken. I don't remember exactly, but
Okay, we can. If I write 1 here, what do I get? 15, right? It is not
15,
3,
yeah.
but 15, right? What was in the
Okay,
second
15,
case?
yeah.
Second case was 5, and then it was -5. Do you see that? What is happening to these values? Decreasing. Always decreasing. Do you see that? Rate of change was highest when the frog leaped, and then it became almost, it is negative, right? It went from high value to low value to 0 somewhere, and then negative, correct? Is this clear to everyone?
So, sir, we always check for the slopes, right? When asking if
I'm
it's
saying, what is the rate of change? What is the rate
right.
of change of this rate of change? Rate of change of the gradient or rate of change of the slope. You understand? How is the rate of change changing? How is the rate of change changing? It is decreasing. It went from 15 to 5 to -5. Is it clear? Do you see the shape of the curve? This shape is called concave down. Whenever the shape of the curve is concave down, rate of change will be decreasing. If the shape of the curve is concave up, rate of change will be increasing on the graph. You get the idea. Very important question from calculus point of view. You can see here, if I draw a tangent, it is negative, right? Slope 0, and here positive. Do you see the rate of change goes from negative to positive? It will be a kind of a straight line. Do you see that? It is increasing. In this case, this is also a straight line, but coming downwards. You get the idea. Very important concept to remember. Well, this is your assignment. You need to answer these questions at home, correct? Okay. So I'll just share the video with you. You'll have the question. If you want, you can take a picture because it will take about a couple of hours. Only tomorrow the video will be there. Okay. Let's move on to some questions which I think we can discuss one by one. Vishruta, can you read the first question and answer, please?
A house was bought 6 years ago for
350,000.
35,000.
350,000.
350,000. If the price of a house is 500,000 now, what is the average annual rate of change in the value of the house as a percentage?
Tell me the answer.
I would do
Yes.
over it would be over 6.
You will find a value, correct? After this value, this is average rate of change. Now tell me, how will you calculate? What is the average annual rate of change in the value of the house as a percentage? How will you calculate this average rate of change as a percentage? Tell me this, Vishruta.
Divided by 100.
Divided by the original value. Let us say we get this as average rate of change, right? We'll divide this by the initial value, which is 350,000. Is it okay? And multiply by 100 to get the average rate of change as a percent per annum. Do you get the idea now? Make a note of this statement. This question will be there in the test and you will not understand what does it mean. So average rate of change can be written as a percent also. Is this clear? Perfect. Hamza, read the second question and answer.
Sure. The population of a town is modeled by P over T equals to negative T squared plus 12T plus 4, where P of T is the size of the population, 1,000, T is the number of years since 2005. What is the average rate of change in the population size from 2010 to 2016?
Tell me how you find the answer.
What is it? Okay. So P of t. So what I would do is that for every year I would plug in a value for t and solve it from there. And then once I find 2 points, I would
What year will you plug in?
the 2010 to 2016.
Wrong answer.
The size of the population in thousands and t is the number of years. Okay, sorry. Years since. So first I start with 5 from 2010 to 2005 to 2010. So I'd start with 5. I plug in
Yes.
5. I plug in 6. I plug in 7. Go from there.
So when you do this, 6, do you understand? You will do plug in 11 because it is since 2005. You're not going to plug in 2010 or 11. It is since then. And then you'll divide definitely by 11 minus 6, and you'll get an answer. Let's call this average rate of change. What will be the answer when you write in words? You have to write your answer in the words. What will be the population? Will it be this number or what? Read the question once again.
What is the average rate of change in the population size from 2010 to 2016?
What will be the
So
answer?
you only want the rate of change from the intervals of like 2010 to 2016. So
Population is in thousands. Let us say you get 6 as your answer. You will write 6,000.
but what about the interval 2010 to 2016?
I've written 11 minus 6. You'll calculate this. That's okay.
Okay. So you don't want it like from 2005, right? That's why I'm just asking.
No. It is from this. So that is your reference frame, right? So in between somewhere, correct? Just as we took from the second. You get the idea, right?
Yeah.
So that is how we are going to answer this particular question. Now, I'm going to share with you so many other questions. We'll end the class. But here's your question number 3, which you need to do on your own. But in this question, we are given you the values in the table, right? So basically, the value could have been given you as a point, could have been given in the form of a function, as we saw, or just a table. Now here also, we are adding one more dimension to this. And I like Akshat, can you please read what is the hint given to us?
Yes, sir. The hint says find average rate of change using the preceding and following intervals. Instantaneous rate of change can be estimated by the average of the results of the above averages.
Very good. So basically here, I'm switching over from average rate of change to instantaneous rate of change. The question really wants me to find, can you read, Akshat, this question?
A basketball player attempts 3-point shot. The table of values below shows the ball's height above the ground for various times during its flight.
Correct. And then this statement.
Estimate the instantaneous rate of change in the ball's height at t equals to 0.5 seconds.
We are trying to find instantaneous rate of change, not average rate of change, at one point, which is 0.5. You get the idea? This is the next chapter. How are we going to do it? We will find the average rate of change in preceding case, that is from 0.25 to 0.5, correct? And we'll also find average rate of change in the following case, which comes after, and then we'll average it out to get the average rate of change at the center. That will be very close to the instantaneous, and therefore we are saying estimate in our question. Is this all clear to you?
Sir, this is what we did for physics 2. This is exactly what we did. The preceding and then,
this is physics, right? So rate of change is a huge thing. Velocity, speed, acceleration, you do all that, displacement, position. This is all that, correct? Because what is mathematics? Mathematics is modeling the real life situations, correct? So all what you do in physics is a part of mathematics. We model what you really do, right? So that's what it is. Is this clear to everyone, correct? So we'll end our class here today. And next time we'll start from here, instantaneous rate of change. Perfect. I'd like you to quickly summarize today's learnings. And if you have any difficulties, also share while you are, telling about today's lesson. Vishruta, can you please tell me, what did you learn today?
I learned how to apply the rate of change and what we learned back in grade 9. And I learned like the different applications and the different type of questions I might get.
Correct. Hamza.
I kind of reviewed how to find the slope. I kind of already know how to do that, but I didn't really know about rate of change. So I kind of learned to apply how to find the slope and then apply it to rate of change. That was sort of me. And the tangent, secant lines.
Yes. Ankita.
This was again like a review of physics. I do remember a lot of like rate of change being used in that course. And so like although I missed some of the class today, I think I pretty much understood like those few questions that we did, but of course I will practice more.
Yeah, watch the video. Yeah. Akshat.
Yeah, sir. So I found it really cool to see how we can combine the secant and the tangent. And then because this is really just pre-calculus, right? Where we're getting into calculus. So I found it interesting how really math and physics go hand in hand and how this is going to lead us into calculus.
There was a very important example which I took. Find equation of a tangent line at a point on the circle. Now that circle was at the origin, so we knew 2 points for the circle, one at the center, the other one where the tangent is to be drawn. So we actually took the slope of the radius, the secant, which was the radius of that circle, right, from 0 to p, and negative reciprocal gave us the slope of the tangent line. That helped us to give the equation of the tangent on the circle. Very important example, so remember that also. Perfect. So we'll end our class here today. Thanks a lot. And we'll begin from next class from instantaneous rate of change. Okay? Thank you. Have a great day.
Thank you, sir.
Bye.
Thank you.